Okay, so the final thing we need to be able to do is we need to be able to find exact value by hand, and we also need to be able to check our answers using a calculator. So I'm going to walk you through how to solve these by hand, and then I'll create a screencast to show you how you could type this into a graphing calculator. Okay, so for problem number 5, we have common logs here, log base 10. So I'm going to go ahead and start by just condensing this down and then comparing to that base 10, okay? So I'm going to start by taking that 2 and making it an exponent. Same with the 1/2, make that an exponent, okay? So this is really going to be log of 50 squared minus the log of 625 to the 1/2 power, okay? Now, 50 squared is 2,500. And 625 to the 1/2 means the square root of 625. So that's going to be a 25 inside the second log, okay? So then next up from there, we're going to condense those down. Because of the subtraction between, I can turn this into a division problem. 2,500 over 25. And then simplifying that division gives me the log of 100. And back in the first video, we talked about how to find log of 100, because remember, this is log base 10, and then this is 10 squared, so our final answer is a 2. Okay? So this big, long expression that we started off with, that 2 log 50 minus 1/2 log 625, is really just a difficult way of writing the number 2. Okay. For this second problem, problem number 6, we're looking at natural logs. Okay, and there's actually 2 ways you can do this. You can start by pulling in exponents and condensing that way, but we can also say, well, this is really just 4 log base e of e squared minus 3 log base e of e plus, and we already talked about natural log of 1. I'm just going to leave that natural log of 1 right there, okay? But if it helps you visually to see log base e when you're trying to do exact value, that's okay to write. This step really is not necessary if you recognize that natural log ln is log base e, okay? But again, if seeing it helps you to recognize that you have same base right here and right here and right here and right here, then go ahead and write it, because if it helps you, then I want you to do it. If you don't need it, then go ahead and just write your next step. So this is really just 4 times the exponent, which is a 2. And this is minus 3 times the exponent inside was a 1 here, because that was just e, or e to the first power. So think of it like there's a little 1 right there. And we talked about how the natural log of 1, or the log of 1, or log base 7 of 1, and whenever there's a 1 on the inside, that means we're really looking at 0 for a value. So we have 8 minus 3 to get a final answer of 5. Okay. Now I am going to show you another way that you could have done this, okay? So there is a secondary way that you could have done problem number 6. So I'm going to erase what I've written and show you that alternative. All right, here we go. So if that first method worked for you, then go ahead and stick with it. If not, then here's your alternative. If you see this and you say, oh, look, a coefficient can become an exponent and a coefficient can become an exponent, you can absolutely start there. That would give you the natural log of e squared to the 4th power minus the natural log of e to the 3rd power plus the natural log of 1. And then power to a power you would multiply, so that would be the natural log of e to the 8th minus the natural log of e to the 3rd plus the natural log of 1 is just 0, so I'm going to write the 0 at this point. And then from there I could say, all right, the first one is log base e of e to the 8th, so that's an 8, minus log base e of e to the 3rd, that's a 3, plus 0, and again, I get a 5. And we could have even continued to condense. We could have said that this over here would have been the natural log of e to the 8th over e to the 3rd, and then we would have had the natural log of e to the 5th, and then I would have still gotten a 5. So there's actually lots and lots of different ways that you can go ahead and do a problem like number 6. There's no one right or wrong way to do it. As long as you're showing your work to support your answer, that's all that really matters.